Okay, today's lesson is about absolute value functions. And we're going to talk about graphing them today. And remember, as we're doing video lessons like this, try to work on my handwriting. It's not going to get a ton better. But the other thing that you got to be aware of is the whole point of doing a video is that you can pause it and you can go back. So that I try not to make the lesson too long in minutes so that you guys can actually go back and do those things. So our essential question for the day is, what are the features of the graph of an absolute value function? Okay. And then our mathematical practice standard today is modeling again. So again, notice that's showing a representation of whatever our data is. So it has to do with graphing. And so we're doing a lot of graphing today. That's why it's a modeling standard. All right, so the first thing we're going to do is we're going to work through the Explore one. And we're going to be graph and analyze the parent function of the absolute value function. So hopefully you know this from other classes, that absolute value is written as the x bars, and it represents the distance between 0 and x on the number line. As a distance, absolute value is always non-negative, so we tend to think of it as always a positive number. For every point on a number line except 0, there's another point on the opposite side that is the same distance from 0. And really, that distance from 0 is really what absolute value is. So for example, both 5 and negative 5 are 5 units away from 0. Thus, the absolute value of negative 5 and 5, or negative 5 equals 5, and the absolute value of 5 equals 5. And then this is a picture of what they're talking about. Now, this is kind of where it gets a little bit tricky and more algebra comes in. So the absolute value function, absolute value of x, can be defined piecewise. So what that means is, in order to take this and break this up, you can break it into two branches, because absolute value of x really means it could be a positive x or a negative x. The positive x is when it's greater than or equal to 0. And then the negative x is when it is less than 0. And honestly, it doesn't matter where the equal to sign is. When x is a non-negative function, it simply returns the number. When x is a negative function, it returns the opposite of x. All right, so an absolute value function of x can be defined piecewise. So they gave us that. We already talked about that part. So we're supposed to complete the input-output table for x. So, and remember, with piecewise functions, you have to plug it into the branch where the x value makes sense. So we're looking at the x value equals negative 8, which is less than 0. So it would go into the bottom part of the function. If I plug a negative 8 in there, it's negative 8. So it's going to turn out to be positive 8. If I plug in a negative 4, it would be negative 4, because we're still in that bottom branch. So it's going to be positive 4. 0 will get plugged into the top, because that's where the equal to part is. I plug a 0 into x, I get 0. I plug a 4 into x, and I get 4. And I plug an 8 into x, and it returns an 8. Then it wants me to plot these points. So I'm going to plot, and notice the graph is scaled funny. It's scaled by 2s. Okay, so each one of these represents a 2, and that's going to give us some issues with counting here in a little bit. So we're going to go negative 8, 8, negative 4, 4, 0, 0, 4, 4, and 8, 8. Now, one of these things is we're talking about absolute value. That V is important. Absolute value function makes a V shape. So we connect the dots, making a V shape. Really should put arrows on the end. So that's what the parent graph looks like. And it's kind of hard to tell on this one, but you'll notice that it goes through the point 1, 1 and negative 1, 1. So those are kind of some reference points that they talked about when we did parabolas as well. So we're going to examine the graph of f of x equals absolute value of x and complete the following statements about the function. F of x equals absolute value of x is symmetric about, so if I look at this axis here, it's symmetric if I fold it on that axis, about the y axis. And therefore is, well, one of the things about symmetry is we kind of briefly talked about even and odd, so this is actually an even function, very similar to a parabola. The domain. So remember, domain is your x values. So I'd probably rather do those off the graph. So my x value, the smallest x value, the arrow means it goes to negative infinity. I'm going to use interval notation because that's what I prefer the most. Negative infinity, and the arrow going the other direction in the x direction means positive infinity. The range, and this is important because your homework asks you about domain and range, but not many of the examples do. The range is going to start down here. So starts wherever that vertex point is at. So the y value there, notice the y value is 0. So it's going to start at 0, probably closed, and then it's going to go it keeps going up and up and up and up because of the arrow, so that's positive infinity. You could have also probably said that y is greater than or equal to 0 for the range as well. Let's see if I can get the page to turn. Oops. Sorry, hang on. My presentation went crazy. Keep. Alright. Where are we at? Okay, we're right there. Alright, so we need to go here. Where's that? Sorry. Where did my PowerPoint go? There it is. Alright, hit that again. Okay. So this one, I'm not going to do exactly what the book does with this one. So it says to reflect here, we're supposed to use the definition of absolute value function to show that it's an even function. Well, to show that it's an even function, we need to show that f of x or f of negative x ends up equaling x. That's the definition of an even function. But back in the example here, or the Explorer, we talked about that we can define that as a piecewise function. So really, we have that f of x equals x, and f of x equals negative x. So what I'm going to do is I'm going to but we should get back to really this original, which is the absolute value of x, which is just x. So when I plug in a negative. So I'm just going to show the steps for plugging that in. I'm not going to go through the big explanation that the book does. So I'm going to plug in a negative x here. And that's not going to work so good, is it? Alright, so when I plug this one in, I get negative x. When I plug this one in, I get negative x. So that one's going to go positive. So that one goes back to the original function. Let me read through really quick. Function, there are 2 cases to examine. All right, I'm not going to worry about showing this. We're going to go ahead and skip over that part. Let's go to the next one. All right, so let's get into explain. I'm going to do it their way once, and then I'm going to show you guys a shortcut. They're really trying really hard in this book to show you all the conceptual knowledge, so you understand the concept of it, and then sometimes it's just good to get down to the nitty-gritty of it. Before we go too far into this, actually, let me see. Let me hit this really quick. Actually, I think I can get out of it. Keep it. I want to do Control M. Okay, so let's go and talk really quickly about what we talked about with parabolas. Okay, oops, sorry. That is, yes. Is it in the presentation? Sorry, I'm doing a lousy job tonight. Okay, let me go to that blank one. Yes. Here. Okay. All right, so the other week we talked about y equals, they had an a out here and a 1 over b here, x minus h squared plus k. So that was a parabola. And remember that this did a translate. Remember, your sign has to change when you come in or out of parentheses. A lot of us were getting that wrong on the quiz. So that does a translate. If it's remember, you change your sign. So it could translate left or right. So if it's negative in here, it goes to the right, which is intuitive. So it's actually the negative goes to the right, the positive goes to the left. The K does a translate, and that affects your Y value. This one affects X, this one affects Y. So it's going to translate up or down. It translates up if it's positive and down if it's negative. So the H one is opposite sign, the K one is whatever the sign is. This does the horizontal, stretch, or compression. And really, I mean, it's going to kind of just affect the slope of the thing for us here today. This one is, again, it's an X value effect because it's inside the parentheses. This one here is the vertical, stretch, or compression. Okay, and it affects the Y value. All right, so now let's look at today's function. So our new function is y equals a times the absolute value of 1 over b x minus h plus k. The only thing that changes, we swap these absolute value signs for the squared. It's the exact same function. This is going to do the same compressions. This is going to do the same translations. And this is going to do the same translations. It's identical. So this might be something you might want to pause the video and put that out in the left-hand column for yourself. All right, let's see if I can get the slides to move now. Oops. Okay. All right, so we're going to go back to this one here, and we're going to talk through with the way they did it, and then we're going to go ahead and highlight. Then I'm going to show you the kind of a shortcut here. So we're going to apply general transformations to absolute value terms by changing the parameters in this equation, which we just talked about. The vertex always comes from HK. And notice that's because the reason we change the sign is because that's a positive H here. When it goes in there, the function makes it negative. It's just part of the function equation. Use the vertex and 2 other points to help you graph. They're talking about these 2 other points. This was the point 1, 1 and 1, negative 1. Those were also our reference points on the parabola. So this is the function they gave us. So it doesn't look like it has a b value. It gives us the vertex, or the vertex of the parent is 0, 0, which we saw in our explore question. So the vertex of g of x will be the point to which 0, 0 is mapped by g of x. G of x involves a translation, so notice. The translation comes from here. Remember, here and here. This is going to move the x, that's going to move the y. In or out of parentheses or absolute values, you switch the sign. So right now it's negative. We switch it because it goes 5 units to the right. You're outside the parentheses or the absolute values, you keep the sign, and so it's negative, so we go 2 units down. So the vertex is 5, negative 2. Personally, I would graph that and watch your graphing because it's scaled by 2s. So we would go ahead and plot 5, negative 2. Now, this is the trickier part. This is the part I don't agree with what they've done, but I'm going to show you how they do it. If you like it, great. If not, I'm going to show you a shortcut. Next, determine the location in which each of the points, 1, 1, and 1, negative 1, will be mapped. Okay, so the x value, remember they kind of wrote a temporary function, or a temporary kind of function for the coordinates when we did the parabola. So the x value, the only thing that's affecting the x is inside those absolute values, and it's adding 5. So the x value is plus 5. The y value is being affected by the 4 in front, and so it's being scaled by 4, and it's being subtracted 2. So we would say 4y minus 2. So that's what the transformation we're really applying to this function. So I would plug these numbers in. That's what they did right here. So they plugged in, where they did 1, 1 first, they plugged in a 1, they added 5 to it. That gave them a 6. They plugged in a positive 1 for that positive 1 part of the point. So, oh, and they did absolute value. Sorry, can't lose the absolute values. 4 times absolute value of 1 is still 4, minus 2 is 2. And they plotted the point 6, 2. Then they did the exact same thing with negative 1, 1. They plugged it into these formulas. They got 4 and 2, and they plugged it in. All right, I'm going to show you the way I would do it now. I graph my vertex, okay? I don't need to go through all of this. If you notice, and you look right here, that and the b value give you a slope of the line. These are just two different lines. So I'm going to count that slope in both directions. So this is a slope of up 4 over 1, right? Rise over run. So I'm going to count up 4. It's going to be trickier on these graphs because they're scaled by 2s. You could add your own hash marks in if you want. So if I think about that, up 4, so let's see, 1, 2, 3, 4, and then it has to go over 1. So over 1 would just be 1 over. There you go. Okay, I'm going to count it up again. Up 4 over 1, I've got the V. So there's your nice little shortcut to graphing. Really, you've got to be able to read your vertex, understand the translation and any of the stretching or compression, and then plot those points using you can use my shortcut. Okay, so I'm not going to fill out every little piece of this skeleton here because I think it's way too much. So we do need the vertex, okay? So let's just think about the vertex, and then let's fill in the translation part, okay? In or out of parentheses or absolute value, you change the sign. So that's a positive sign. We change it to a negative. Write that in the left-hand column. In or out of parentheses or absolute value, change the sign. It's something that we've been missing, so you guys really need to focus and get that right this next time, okay? And then outside the parentheses, keep the sign. If you want to write that down, you can. Pause it. Outside the parentheses, keep the sign. All right, so let's talk about that translation now. The x value went to the left. So the translation of, let me make sure I write it down, of 3 to the left. The left takes care of that negative for us. And 1 unit to the 1 unit up. All right, so we've got that taken care of. I should plot that vertex. That's the next thing I'm going to do. So I'm going to go out negative 3, and again, it's scaled by 2. So 1, 2, 3, and sorry, I made the mark. And then I have to go up 1. So there's my point. Okay. All right. All I'm going to do now is I'm going to, instead of dealing with all of this here, I'm going to deal with the slope. And really, thinking about absolute value, the slope is going to be whatever these two numbers are here. So it's a 1 times 1/2. So your slope value is really 1/2. So I'm going to do a rise of 1 and a run of 1/2. So I'm going to go up 1 and over 2. So 1, 2. We do the same thing this direction. And go up 1 and over 1, 2. And I get the exact same thing I would have gotten had I gone through all of this over here. Okay. All right, we're going to try this, and I'm not going to worry about the points. Okay, let's just go ahead and go through this piece, okay? So all they want us to do is literally find the vertex and the other 2 points. We're also on this one. Let's talk about the domain and the range because that comes up in the homework assignment, okay? All right, so first thing I'm going to list is the vertex. Sometimes I will just write a V for that. All right, so in or out of parentheses, what do we got to do? Change your sign. So we're going to swap it to the -6. Outside the parentheses, keep the sign. Plot that while you're thinking about it. So we're out -6. Remember, we're scaled by 2. So 1, 2, 3. I lost that pretty quick. It's not scaled by 2s. It's scaled by 4s this time. That's even worse. Let's try to figure that out here. Okay. Let's see. So it's got, each one of these is 4. So 1, 2, 3, 4. 5, 6, and then I got to go up 4. So that's 1, 2, 3, 4. So there's my vertex point. I don't like the scaling on these graphs at all. So to find our other 2 points, we're going to count this slope. It doesn't matter positive or negative. Actually, the negative in front of this will make it go down. This other negative back here on this one, because it was inside the absolute values, it would go positive. So that's why it was opening up. All right, so that negative, I'm going to count that negative down first. So I got to count down 1 and then over 5. I'm going to put my little marks in here. Okay, so down 1, over 1, 2, 3, 4, 5. I think it's going to land us right there. And then we got to do the same thing this way. We already know the down 1. Let's see. 1, 2, 3. Okay. So let's see. Down 1 over 1, 2, 3, 4, 5. It should be symmetric. Okay. If you want to go ahead and read those points off the graph, you can. Okay. All right. So let's talk about the domain. The domain is all the x values. The x value that's the most to the left because of the arrow would be negative infinity. The one that's most to the right would be positive infinity. The range is going to start here. So that number is 4. If you want to do a closed, that's fine. And then the arrows indicate a negative infinity because it's going down. Another way you could write the range and what the book might do is they will probably say y less than or equal to, because it's underneath it, it's pointing down, and then whatever that y value was for. So either one of those is acceptable for the range. All right, so now that we've learned how to graph, I think we learned how to write equations. Okay, so we're going to write absolute value functions from a graph. So they're going to give us some information here. They're going to tell us what the b value and the a value is, and I noticed they did this in the homework assignment too, so we're going to go with the way they do it. We're going to do one where it gives us the a and one where it gives us the b, I think. So if an absolute value function is given in this form, has values other than 1 for both a and b, you can rewrite the function so that you have at least one a or b, or at least one of a or b. So the value of at least one of a or b is 1. So when a and b are positive, so basically, you notice look what they're doing with this. They're either putting it inside the absolute values or outside. It doesn't matter. That's why I could just count that slope out when we were graphing it. When a is negative and b is positive, you can move the opposite of a inside the absolute value. So a is negative, b positive, opposite of a inside the absolute value. So if a is negative out front, move it inside. This leaves negative 1 outside of the absolute value symbols. What they did was they moved the 2 inside and left a negative 1 out front. When b is negative, you can rewrite the equation without a negative sign. So rewrite without a negative sign because of the properties of absolute value. In this case, this case has now been reduced to one of the other 2 cases. All right, I don't know why it doesn't like my... Yes. Okay, so we're going to go ahead and step through one of these. We're writing the equation, and then we're going to fill one in ourselves. So in this case, they told us, hey, a equals, hey, a equals 1. So they're giving us that information, which it does give it to us in the homework as well. Okay. The vertex of G is at 2, 5, and you could read that off the graph. All right. So I would probably just go ahead and substitute that in automatically. So now, when you're going in or out of parentheses, you change the sign. So notice it was a positive 2 for our h here. We changed it to a negative 2 inside the parentheses. Choose a point on g of x like 6, 6. So they're going to give you the graph. You're going to pick a point off the graph. So they say 6, 6. They want us to substitute these values into g of x and solve for b. So all we're going to do is take this function, plug the y value in for g of x, which happened to be a 6, plug the x value in, which also happened to be a 6 for the x, and then we're going to solve for b. So they plugged those values in with the vertex in there. 6 minus 2 is 4. Then they took this 5 and moved it to the other side. You'd have to move it by subtraction. So you're going to do 6 minus 5 is 1. And then in order to undo absolute value, you have to have a positive expression and a negative expression. That's how we undo absolute values. So, which we're going to see a lot more of in the next day or two. And then we're going to get b by itself. Okay, so this is b by itself. They skipped a step. So we're going to, in order to get rid of the division, we have to multiply. So we basically did 1b equals 4. And then we have 1b equals negative 4. They didn't really skip a step. They just didn't, you lost the 1. So they dropped their 1s off here. So that b has to be either 4 or negative 4. Based on the problem conditions, consider only b equals 4, substitute into g of x. Because remember, the absolute value is going to make it positive anyways. So all they did then was substitute this back in with the 1/4 in there. All right. I think we've got 3 more to do. Okay, so now we're going to kind of step through it with their little skeleton here. Okay. So this time they're letting b equal 1. Sorry. Okay, so they're letting b equal 1. So we're going to, this time we're going to have to solve for the a. So the vertex of g of x is at, we can read that off the graph. We are saying it's at 1, 6. This means that h equals, so the h is the x value is 1 and k equals 6. The value of b is given, b equals 1. So let's go ahead and substitute in. So they're going to substitute in the 1. Notice we flip the sign and the 6. Choose a point on g of x with integer coordinates. So they're saying that we can pick this point that they marked for us, 0, 3. All right, we're going to plug in our h and our k again. And then we're going to plug in 0 for the x, which they did for us. And then 3 for the g of x, because that's the y value. Remember, g of x is the y value. All right, we're going to solve this now. So they skipped a step, okay? 0 minus negative 1 is negative 1, and then they also at the same time subtracted 6. Oh, no, they didn't. Sorry. Going too far ahead. They just left it as 3. Now we're going to subtract the 6. Personally, I would have done that all in one step. 3 minus 6 is negative 3, so there's your a value. So we got to substitute that a value back into this equation. So we've got negative 3, absolute value of x minus 1 plus 6. Now, that makes sense that it's negative because look, your graph's upside down. Okay. One more, we're going to try to do this on our own. Okay, so the first thing we're going to do is we're going to read the vertex point off of here. Okay. So your vertex point, I'm just going to label it with a V. All right, so is, let's see, it looks like we're scaled in 2. So I see 1, 2, 3, 4, it looks like negative 5. And then we're down 1, it looks like it's negative 1. So negative 5, negative 1. All right, let's fill in what we know. So g of x equals, we don't know the a, we don't know the b. Remember when we come in or out of the parentheses, we change the sign. So it's a negative here. We're going to make it positive 5. On the outside, we leave the sign alone. It's a negative 1. Okay, on this one, I'm going to tell you, they didn't do us a very good job, that we're going to let a equal 1. Okay, so we know that a is going to be a 1, which means that we've got to solve for the b value. Okay. So I need to pick another point that I know on this graph. So this other point that I know is probably right here, that one. It's on the graph, and it's out 0 and up. Okay. There might be another one we can read. That one just happens to be the easiest. It's not great because of the way they're scaling the graph. All right, so for the x value, I'm plugging in a 0. For the a value, I put in a 1. So that kind of disappears. So I'm putting in a 0 for the x. And then for the y value, which is the g of x, I'm putting in a 9. So we're going to go ahead and solve this. I'm going to do a couple steps at one time, because algebra 2 means we do two things at once. So we have 1 over b. 0 plus 5 is 5. Now, there's no reason I can't add this 1 at the same time and save myself a line of work. So 9 plus 1 is 10. All right. Then I want to... interesting. Okay, so then what I want to do is I want to get the b by itself. So remember, when I come in or out of absolute values, or when in order to split that, I have to split that into two different answers. No, oh, it's because of the b being on the inside. All right, so if I was going to move this over, yeah, okay, so I have to do 10 equals 5 over b and negative 10 equals 5 over b. And the reason that's different is because I'm coming out of those absolute values. All right, so I'm going to multiply by b on both of them. So 10b equals 5, negative 10b equals 5. And then I'm going to divide the 10 back over. So b equals 5/10, and b equals 5 divided by negative 10. We reduce that to 1/2 and negative 1/2. So what they're basically, and remember they said that the negative 1/2, we kind of discount that one because of the absolute value. So I'm going to substitute the positive 1/2 in. This is going to look weird. Okay, so I'm substituting into here. G of x equals, I don't have an a value, I've got 1 over 1/2 x plus 5 minus 1. Now, we don't like the way that fraction looks. So remember, when we have a double fraction like that, it's like saying 1 over 1 divided by 1/2. So I flipped the bottom and I switched to multiplication. So it's really a 2. So I could replace that with a 2. Sorry. So you have g of x equals the absolute value of 2 times x plus 5 minus 1. Okay? All right, that's as far as we're going to go today. We're not going to do explain 3. Okay? We're going to leave that for some other time, maybe. So we're going to go to elaborate. So in order to get your class points for the day, you need to finish the elaborate. So you need to elaborate 5, 6, and 7. Okay, you should have enough information to do that.